Okay, we're looking at 6.4, similar and congruent figures. And we need to know what similar figures are. Um, Similar figures are two figures that have the same shape, but not necessarily the same size. So I've got two examples of similar figures down here. Notice that this one, this little triangle right here, um, is smaller than this one, but it does have the same shape. And if we were to blow this thing up and make it bigger and tilt it a little bit, we could put it right on here and you wouldn't see any difference, okay? So this and this, these two shapes are definitely similar, okay? And I have two shapes here. Um, Notice that this one is larger and it's also kind of tilted a little bit differently. But if I were to blow this one up, this shape would be the exact same size and shape of this one. Okay, now let's look at corresponding parts of figures. They are the sides and angles that have the same relative position. In other words, if I were to take this shape right here and blow it up to this size, the corresponding parts would be the parts that would be the same size after I did that. So this side right here corresponds to this side, okay, because they have the same relative position. This side to this side, this side to this side, and this side to this side. Now the corresponding angles, same thinking goes with that. This angle right here corresponds to this angle to this angle, this angle to this angle, and then this angle right here to this angle. Okay? So again, if we were to blow this up and set it on top of this one, corresponding angles and corresponding sides would be the same. Would be the sides would be the same size as the sides in this one. Those would be the corresponding sides. The angles are in the same position. Okay, let's look at the next page. Here we have this. Now this is a similarity statement. Okay, and this little shape obviously is a triangle, and it means triangle ABC, which is this triangle right here. Okay, so we see this shape, and that's telling us this is a triangle. We see this shape, it's telling us this is a triangle. This right here means is similar to. Okay, so this is a similarity statement. Triangle ABC is similar to triangle DEF. Okay, that means it's the same shape, not necessarily the same size. Okay, but there are some things we can look at in this similarity statement that tells us a little bit about these two triangles. Okay, we need to look at the order in which these letters are, because it's going to tell us something about what angles and sides correspond to what the other angles and sides. So this angle right here, angle A, we can tell by the similarity statement corresponds to angle D. Those angles are the same exact size. We call those congruent when they're the same, they have the same measure, okay? And we also can see that B and E correspond to each other. So this angle E and this angle B are congruent, meaning they have the same measure, okay? And also C corresponds to F. So F here and C here, and I'll just kind of denote that by making that 2. They have the same measure, so they are congruent. So we can see by the similarity statement which angles correspond to each other without even having to look at the triangles. Now we also know something else about similarity in similar shapes. The ratios of the lengths of corresponding sides of similar figures are equal. That means we can make a ratio comparing the similar or the corresponding sides, and those ratios will be equal for every set of sides we do that with. Okay, and I can look up here at this, and it's going to tell me what side corresponds to what side. Okay, now you have to have a side has to have 2 points. Okay, AB is a side. That is a side length. Okay, that corresponds to DE over here. Okay, AB corresponds to DE. That means if we were to blow this triangle up and make it bigger, this side length would be the exact same as this side length. Okay, but they're not right now. This one is smaller, but that one does correspond, and we can make a ratio out of it. AB to DE. Okay, what are the other ones that correspond to each other? Well, I can look up here and see that BC corresponds to EF. So BC is 3, EF is 6. Okay, also I can see that AC corresponds to DF. AC is 5, DF is right here, which is 10. And notice that all of these ratios equal the same thing, which is 1/2. And that's true of any set of similar figures. Okay, the ratios of the lengths of the corresponding sides are all equal. Now notice I started with 4 here, which is the smaller figure. Okay, in my next ratio, I need to start with a smaller figure. And in the next ratio, I need to start with a smaller figure. These are all the smaller figure lengths. These are all the larger figure lengths. Okay, I need to keep the data the same. If I start with smaller here, it needs to be smaller all the way across. Does that make a little sense? Hope so. Okay, now this is given to us. ABCD is similar to WXYZ. Okay, and it says name the corresponding angles and the corresponding sides. Okay, well, let's look at the corresponding angles. And I don't really have to look at the sides here or the shapes. I can look at the statement here. I know that angle A corresponds to angle W. And if we looked at these shapes, we could tell that this angle and this angle correspond. If we were to turn this one over, that would correspond to that. So the way I would write that, this is the sign for angle. It's kind of like a slanted L. So I'd say angle A, let's see, we'll just write it like this, is congruent to angle W. Or congruent means they have the same measure. Okay, also angle B right here corresponds to X, so angle B is congruent to angle X. Angle C right here corresponds to Y. Angle C is congruent to angle Y. And then D and Z correspond to each other. Angle D is congruent to angle Z. I forgot. Now this is the sign for congruent. It's an equal sign with that little similarity squiggle on top. Okay, so congruence would mean I have this symbol on the top and then I have an equal sign below. And I didn't go over that. So these are the symbols for angles. These are the symbols. This is the symbol for congruence, meaning their measures are the same. Now let's name the corresponding sides. Well, we can look at here. This statement, AB corresponds to WX. And I can write a ratio out of that. We're going to go ahead and do that. Okay, that also equals BC corresponds to XY. That's going to equal this. CD corresponds to YZ. That's supposed to be a Z. And then AD corresponds to WZ. Okay, there's the corresponding angles. These are the corresponding sides. This is one set of corresponding sides, so on and so on. And these ratios equal each other in similarity. Okay, now let's use that information to answer this question. We know that ABCD is similar to Jklm. Okay, it says find the ratio of the lengths of the corresponding sides of ABCD to Jklm. So it does matter what order we have this in. Remember, ratio is a fraction. The first one is the top. The second one is the denominator, or the bottom. Okay, so I just need to pick any side on ABCD. It doesn't matter. Let's pick AD. Well, that's 4. I'm going to make a ratio. What does AD correspond to in this one? Well, if we can't tell in the shape, I can look at the statement. AD corresponds to JM, and you can see that clearly, that JM and AD correspond. Make a ratio out of that. That ratio, when I reduce it, is equal to 2/3. And I'm done. And it doesn't matter which side you pick, you get the same answer. Let's pick BC to LK. Well, that's 2/3, right? Let's try AB to JK. Okay, that's going to be 8/12, which is going to be 2/3. So all I have to do is do this once. I pick one set of corresponding sides, I make a ratio, and I'm done. The ratio is 2 to 3, 2/3. Next, let's look at this word problem. A soccer field is a rectangle that is 70 yards long and 40 yards wide. The penalty area of the soccer field is a rectangle that is 35 yards long and 14 yards wide. Is the penalty area similar to the field? Okay, so let's look at this. Let's set up a ratio of the corresponding sides. Okay, now this is the long side of the field, this is the short side of the field. Now let's look at the penalty box. What would the long side of the field correspond to in this rectangle? Well, the long side of the penalty box. Okay, so 35 and 70 are corresponding sides, right? And then I've got 14 and 40. Now, if they're similar, those are going to be equal. So what I have to do is see if they're similar. So I'm going to reduce This is going to be, I'm going to reduce by 7, and that's going to be 5. Well, I can reduce by more than that. That's going to be 5/10. I can reduce by 5. That gives, well, I should have seen that. That's 1/2. Okay, so that's 1/2. Okay, does this look like it's 1/2 at all? Not even close. This would have to be 20/40. Okay, so if this was similar, if this rectangle was similar to this rectangle, each of these would be equal to the same thing. Okay, in this case, I don't have 20/40. If this was 20/40, they would be similar, but in this case, these are not equal, so this is not similar. Okay, and it's that simple. Let's look at the next question or problem here. Two figures are congruent. Here's a new word. Well, it's not a new word, but we're introducing it here. If they have the same shape and the same size. That means not only do they have the same shape, they've got to have the same size, so everything must be equal. If two figures are congruent, corresponding sides are congruent, and corresponding angles are congruent. So in similar figures, the corresponding angles are always congruent. But in similar shapes, the corresponding sides, the ratios of the corresponding sides are equal. This one, the corresponding sides are congruent. So J corresponds to P, those are congruent angles. R corresponds to L, K corresponds to Q, sorry, and those are all congruent. JK, right here, corresponds to PQ, those are equal. QR is equal to KL, and PR is equal to JL. Okay, those are in congruent shapes. So let's look at another one with congruence. Now here's a congruent statement. ABCD is congruent to WXYZ. So I want to find the length of WZ. Well, here's WZ right here. What does this correspond to in this shape? Well, if you don't know by looking at the shape, look at the statement. WZ corresponds to AD. How long is AD? 12 meters. So WZ must be 12 meters because they are congruent. Okay, look at angle W. What does that correspond to over here? If you don't know, look at the statement. Angle W corresponds to angle A. What is the measure of angle A? 105 degrees. So the measure of angle W is 105 degrees. And that's what this little m means, measure of angle W, 105 degrees. Okay, and again, if I were looking for CD, AB, what corresponds to AB? Well, WX does. How long is WX? 16 meters. So this must be 16 meters. So in congruent shapes, corresponding angles and corresponding sides are equal. Okay, and that concludes our lesson for today.